Chapter 3, Parallel and Perpendicular Lines. We're going to cover sections 3.1 and 3.2 today. Our objectives for 3.1 and 3.2 are to identify pairs of lines and angles and use parallel lines and transversals. Definition. Two lines are parallel lines if they do not intersect and are coplanar. You have to include in the definition that they are coplanar. Here's an illustration why. My arms are parallel. They're in the same plane. They never cross, right? But my arms now do not cross, but they are not parallel. They're in different planes. These are called skew lines. So you have to also, in addition to saying they do not cross, you have to say they're coplanar or in the same plane. So two lines are skew lines if they do not intersect and are not coplanar. That's a good true-false question. True or false? Two lines that do not intersect are parallel. You're going to say false because not in all cases. If they are non-coplanar, they could be skewed. All right, so if you're doing some type of question involving the definition of parallel lines, look for the word coplanar as well. Two planes that do not intersect are called parallel planes. Your desktop and the floor could be considered parallel planes. They're not going to intersect. The ceiling and the floor, parallel planes, do not intersect. The symbol of two lines together means parallel. Most of the time they're written at a slant. In the PowerPoint they're vertical, but so you know you're going to have line AB, and then you'll have the two lines together is parallel to line CD. It's going to look like that when you write the symbol. The arrow symbols are used to show that lines are parallel. So these little arrows here on the parallel lines, on the two lines, show they are parallel. If you have multiple parallel lines in a picture, you would, if there were other parallel lines that weren't parallel to these two, you would put two little arrows, just like tick marks. As long as they have the same number of little arrows or same number of, if they have the same number of arrows, then they are going to be shown as parallel. The upside down T means perpendicular to. I would use that, I would say AB is perpendicular to segment BC. I'd show it like that. Perpendicular. In a picture, a box symbol, as you can see here, this box says that that's a square corner, that those are perpendicular. Which lines, planes in the figure appear to fit the description? Lines parallel to CD and containing point A. What lines are parallel to CD and contain point A? Okay. Yes, AB. HG and EF are parallel to CD, but they do not contain A. So AB would be the only one that fits that description. Lines skew to CD containing A. Which lines are skewed to CD and contain A? Kayla? AG is one. What's another one? AH. AG and AH. Lines perpendicular to CD containing A. Look for our box symbol, right? Which, yes?
DA.
Segment DA is correct. Or AD. It appears perpendicular and contains a point A. Plane parallel to EFG containing A. Okay, so we've got EFG. It's this bottom part of the cube. It also contains H, but you only use 3 letters to name a plane, so they used E, F, and G. What plane could we name that's parallel to that, containing A? Trent? ABC. We could call that ABC. We could also call it ADC or CBD. Let's see what they called it here in the PowerPoint. Oh, look, they called it ABC. There. Any questions on this? Make sure you go back and review this. There will be quiz and test questions with similar type drawing that you have to answer questions about. So make sure you understand this. Put a star by it in your notes. The parallel postulate. The parallel postulate says if there is a line and a point not on the line, so we've got line L and point P, then there's exactly one line through the point parallel to the given line. There's only one line through P, the red line, that will be parallel to L. Parallel postulate. The perpendicular postulate says that there is a line, so line L and a point not on the line, that would be this point here, then there is only exactly one line through this point that's going to be perpendicular to P. This red line, that's the only line through that point that's going to be perpendicular to the green line. All right, everybody have it? Moving on. Here's an example. Name a pair of parallel lines. Look for the markings. Don't just go by what the lines look like. Look for the markings we use to symbolize these different relationships. Which lines in the picture are parallel? Kayla.
B, F, and G, E.
I don't see it.
C, E.
Okay, they look like they could be parallel. I would say they're probably going to meet up here somewhere. But there's some markings we can use. They're hard to see, but there are markings in the figure that show lines are definitely parallel. Trent, which ones are marked? Yes. These two, right here and right here, they both have 2 arrows on them. That shows they're parallel. So the parallel lines would be MD and FE. Perpendicular lines. Which lines are perpendicular as marked in the figure? Levi, what do you think? DA and BF, yes, that's correct. The vertical line and then DA. Let's see how they named it. They named it MD. AD and MD are the same thing. So MD and BF would be perpendicular, as shown by this box. All right, now, is FE parallel to AC? Explain why or why not. Obviously, in the picture, we can tell AD is not, that FE is not parallel to AC. But what would be a sound argument as to why, besides just going by what it looks like? Why can we say that it's not? I'll give you a clue. It has to do with the point M. This is an application of the parallel postulate. We have FE. Here's point M. We already said that line AM is parallel to FE, right? The parallel postulate says through a point not on a line, that point being point M, there's only one line parallel to FE. If AC were also parallel to FE, that would make two lines parallel to FE. That can't happen. So we know, because we already determined MD is parallel to FE, AC can't be. That's our explanation. So I would accept, they explained the parallel postulate, but you could just say no because of the parallel postulate. That's all you need to say. Anybody been to Niagara Falls? Okay, I think that's probably the U.S. side of the Niagara Falls there in the picture. Transversal. A transversal is a line that intersects two or more coplanar lines at different points. So it's simply, I've got two lines, and the line crosses both the lines. That's a transversal. I've got a line and two lines cross it. Or no, I've got two lines and the line cross it. That's a transversal. Corresponding angles. Corresponding angles. Two angles are corresponding angles if they have corresponding positions. In other words, if I took this intersection that has the 2 by it, if I took this intersection and I slid it down and I put it on top of the intersection below, the 2 would be on top of the 6. That shows they correspond. They hold the same position. At this intersection, 2 is in the upper right part of the intersection. 6 is in the upper right part of the intersection here. So 2 and 6 correspond. They hold the same position in their intersections. Alternate interior angles. The name tells you where they are. Alternate means opposite sides of the line. Interior means inside the two green lines. So that would be alternate interior angles would be 4 and 5. They're on opposite sides of the red line and they're inside the green lines. So 4 and 5 are alternate interior angles. I could also call these two angles as alternate interior angles. We just didn't label them. But those are alternate interior angles. There's more than one pair inside the two lines. Alternate exterior angles. The name, again, tells you where they are. They're on opposite sides of the line, and they are outside of the two lines. So an example of alternate exterior angles would be 1 and 8. 1 and 8 are alternate exterior angles. Consecutive interior angles. Consecutive tells you they are next to each other. Interior means they are inside the two lines. Consecutive interior angles would be 3 and 5. There's no line separating them. They're right next to each other. They're consecutive, 3 and 5, and they're inside the green lines. Consecutive interior. There'd be the two on the other side, the two angles on the other side of the red line. That pair would be consecutive interior angles. You need to be familiar with these names and where the angles are. Are there any questions about those terms? All right. So, let's identify all pairs of angles of the given type. So, corresponding angles. Give me a pair of corresponding angles. What does angle 1 correspond to in the picture? Ryan. It corresponds to angle 5. If I took this intersection and I slid it on top of the other one, the 1 would be on top of the 5. They correspond. They hold the same position. Give me another. There's 3 more pairs. Give me another one. Kayla.
6 and 2.
Angle 2 and angle 6. Chapman.
3 and 7.
Angle 3 and 7. There's one more. Angle 4 and what? Eva.
8.
Yeah, angle 4 and angle 8. Alternate interior angles. There's 2 pair of alternate interior angles in this picture. Give me one. Oh, go ahead.
Angle 2 and 7.
Yes, angle 2 and angle 7. Opposite sides of the line and inside the lines. Angle 2 and 7. What's the other pair? Trent.
4 and 5.
4, yes, angle 4 and angle 5. Very good. Alternate exterior angles. Name a pair of alternate exterior angles. Outside the lines, opposite sides of the line. Ellen.
Angle 1 and 8.
Yes, angle 1 and angle 8 are alternate exterior angles. Ryan, give me another one.
3 and 6.
Angle 3 and angle 6 are alternate exterior angles. Good. Consecutive interior angles. 2 pairs of those as well. Give me one. Consecutive interior. Okay, Ryan.
2 and 7.
They are not consecutive. They are interior, but those 2 and 7 are alternate interior angles. Erica.
2 and 5.
2 and 5. Angle 2 and angle 5 are consecutive interior angles. What's the other pair? Ellen.
Angle 4 and 7.
Angle 4 and angle 7. Any questions? All right. Okay, so 3-2. Before we do 3-2, use parallel lines and transversal. That leads into the corresponding angles postulate. The corresponding angles postulate says if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. In this picture, they've got 1 and 5 labeled as corresponding angles. 1 is going to be congruent to 5. We're going to put some of this into action. Measure of angle 1 is 120 degrees. Find the measures of the rest of the angles. So angle 1 is 120 degrees. Let's use, okay, let's use corresponding angles. What can I say? What else can I say is 120 degrees? Kayla.
Angle 8.
Those don't correspond. What corresponds with one? Ryan?
Angle 4.
That's not a corresponding angle. What angle corresponds? Megan?
Angle 5.
Angle 5. So we could say angle 5 is 120 because of corresponding angles. Now let's use vertical angles. What can I say? What else? What other angle can I find by vertical angles? Okay, Kayla?
Angle 4.
Right. Angle 4 and angle 1 are vertical angles. They're across from each other and made by the same lines. So angle 1 and 4 are 120. What else can I say is congruent by vertical angles? What's the same as angle 5? Eva?
8.
Angle 8 is 120. All right, now we can use linear pair. What does linear pair mean? The angles are what? If they're a linear pair, the angles add up to 180. Right. So 1 and 2 are a linear pair, so what can we say angle 2 is? Yeah, it'd be 60. 120 plus 60 equals 180, so that would be 60. Now we can find angle 3 either by vertical angles with angle 2 or by linear pair with angle 1. What would angle 3 be? 60. All right. What about below? Right. Yes, angle 6.
The 60 degrees.
Because of?
It's corresponding to 6.
Okay, that's one way you could have done it. 6 corresponds to 2. 2 is 60, so 6 is 60. What's 7? Somebody else.
60.
7 is 60. I can use any way to say that. 7 corresponds to 3. 3 is 60, so 7 is 60. That's one way I can do it. I could have done vertical angles. 7 is a vertical angle with 6. So they're both 60, or I could have done linear pair. 7 is a linear pair with 5, so their sum must be 180, so we could conclude that it's 60. Alternate interangle theorem. The alternate interangles theorem says that alternate interangles formed by parallel lines are congruent. In this picture, 4 and 5 are alternate interangles. 4 and 5 would be congruent. Alternate extra-angle theorem. It says that if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. In this picture, 2 and 7 would be congruent. They're the alternate and extra angles. They are congruent. That's one of the pairs. There's 2 pairs. These other angles, these 2 would be congruent as well because they are alternate extra angles. Consecutive interangles theorem. It says that when I have parallel lines, the consecutive interangles are supplementary. They add to 180. They're not congruent. They add to 180. Consecutive interangles. 3 and 4. They're on the same side of the transversal inside the lines. They're going to make 180. If you think about it, here's why. 3 is congruent to 3 is congruent to this angle because they're alternate at your angles, right? And that unmarked angle, let's call it x. X and 3 add to 180. So do 4 and x add to 180, right? 4 and x add to 180, not x and 3. X and 3 are the same. 4 and x add to 180. Since x and 3 are the same, 3 and 4 would add to 180. That's a little proof of that. Three and 4 add to 180. All right, example 2. Lines A and B are parallel. So we can use theorems about parallel lines. How can we find the measure of x? Well, they want the measure of angle 4. What would the measure of angle? No, they want the measure of angle x. How would we find the measure of angle x? What would I do first? (115) and x plus 5 don't correspond, so I can't say they're the same. Yes?
We'll find the measure of angle 4 first.
And what would it be?
115.
Why?
Because it's vertical.
Right. 4 is 115 because it's a vertical angle. Now I can find x. How am I going to find x? What am I going to do? Trent.
Add 115 to x plus 5.
Right. Those are 4 and x plus 5 are consecutive interior angles. So I add them together, set them equal to 180. So we'd have 115 and x plus 5. And we would solve for x, and we get x equals 60. Questions? Yes.
Would you just leave it like that, or would you plug it in?
Well, they asked for x, so you could just leave it like that. All right. A little proof here. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. You're going to have to do quite a few proofs like this. There are not many steps, but there are proofs in here involving these relationships. One thing I will tell you on this, if I am proving that the 1 and 2 alternate interior angles are congruent, I cannot use alternate interior angles in my proof. They may not even say, they may not even say that they are alternate interior angles. You may just be given the P and Q are parallel. We need to show 1 and 2 are congruent. You can't just do it in, you could just, if you used AIA, it'd be one step. You'd say 1 and 2 are congruent. Well, you'd have the parallel, and then you'd have 1 and 2 are congruent AIA. You can't use what you are proving in your proof. So without using alternate interior angles, let's prove 1 and 2 are congruent. We'd start our proof with the given. P is parallel to Q. That's step 1, and that's given. What do you think I would say in step 2? What could I say? Where are we going with this? Caleb, what do you think?
Angle 3 equals angle 2, which is vertical.
Okay, we can do that. Angle 3 is congruent to angle 2. That's by vertical angles. All right? What else can we say? What else is 3 congruent to?
1.
Right. Angle 3 is congruent to angle 1. How come, Trent? What's the reason? What are those angles? What's their relationship? They're corresponding. All you need to put is CA. I'll know what you're talking about. CA for corresponding angles, AIA for alternate interior angles, and so on. Step 4. What do I say next, Kayla?
Angle 1 is congruent to angle 2, and would that be a substitution?
Yes, it's substitution. We could be more specific. I would count substitution, but really what is this a form of? Yes.
Transitive.
Yeah, this is transitive. Because it's transitive because we have two things. Angle 1, angle 2 both equal the same thing. They both equal angle 3. When two things equal the same thing and then they equal each other, that's transitive. So the final step would be transitive. Any questions? All right. Here's the proof again. All right, example 4. So we have this picture. Sunlight enters a drop of rain. Different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 equals 40. What is the measure of angle 1 and why? If angle 2 is 40, what would angle 1 be and why? Let's hear from somebody different. Alex, why do you think angle 2 equals angle 1? They're the same. Angle 2 and angle 1 are the same. How do we know that? Which reason? Which one of our relationships is it? Ellen?
Alternate interior angles.
Right. It's alternate interior angles. 2 is going to be the same as 1 is going to be the same as 2. They're both 40 because we have parallel lines. The yellow lines are parallel. The purple lines are transversal. They're on opposite sides and inside, so they're alternate interior angles.